That was a preset. Okay, well, let me share screen. So I guess the recording you're starting here. We're using the first derivative test to find relative maximum minimums of this. So we said first thing to do is find critical points. So take the derivative of this function, set it equal to 0. Well, if I take the derivative of this, if I look at the derivative of 1/3 x cubed, bring the exponent down, 1/3 times 3 is 1, meaning I'm just left with an x squared. When I look at that -5/2 f squared, when I bring my exponent of 2 down and multiply by it, the 2 and the division by 2 are going to cancel each other out, leaving me with just a 5x. So remember, I got to subtract 1 from the exponent. And then the derivative of -14x is just -14. The derivative of 1 is 0. So my derivative will be x squared minus 5x minus 14. I set this equal to 0. And solve. And with quadratics, again, something I was trying to teach y'all or remind y'all of last week, and you saw in the homework, try to factor it at first, right? It's always easier, especially when I see a quadratic function, to factor it, but that won't always be the case. Sometimes you have to use quadratic formula. But here, it actually factors relatively nicely. Okay. This factors into x minus 7 times x plus 2, which means that my critical points, I'm just going to shorthand it CP, from critical points, are when x is -2 and when x is 7. Okay, so this is the first step. This is where my critical or my relative maxes or relative min will occur. But now I need to use the first derivative test to see, okay, for -2 and 7, which of the values are going to actually be a relative max. Okay? So I consider the function my derivative. And as we said before, wherever my derivative is positive, that means I'm increasing. Wherever my derivative is negative, that means I'm decreasing. So if I'm looking for a relative max, I want to see my function going up and then going down, which means I want to see where my derivative is positive, and then I want to see it switch to being negative at one of these critical points. And that is how the first derivative is going to tell me I have that little hump that we always see for relative maxes. So the easiest way to do this is just do a line chart, a sine chart. So just consider a chart for my function, the derivative, and then the points that I need to consider here are my critical points, right? Where my derivative is equal to 0 at -2 and at 7. And I just want to look at the sign of my function, the sign of the derivative, and for everything to the left of -2, between -2 and 7, and then to the right of 7. And there's a couple different ways you can do this. You can remember a bunch of your properties. You can sketch a graph of this function pretty quickly. Or if you just want to keep it a nice simple approach, just plug in values in these intervals, because we're dealing with continuous functions. We're not going to have any crazy jumps. Okay? And we're just considering the sign. So let's just erase this to give ourselves some room to work. I want to plug in a value less than -2 into my derivative just to figure out whether or not my derivative is positive or negative. So a nice easy choice would just be -3, something to the left of -2. So if I plug in -3, this is -3 squared minus 5 times -3 minus 14. And you can finish this value out, but is it going to be a negative number or a positive number? What do y'all think?
Positive, I think. Wait, hold on.
Well, we need to finish out the calculation can, but we just care about the sign. Is it going to be a positive number or a negative number?
I think a positive number.
I'm guessing positive.
Yeah, I see you putting it in the chat as well. Yeah, positive. And if you just need the confirmation really quickly, this would be a 9 plus a 15 minus a 14. And I can already see that this is going to be something greater than 0. Actually, it'll be what, 10? Yeah, it'll end up being 10. I don't care necessarily about the value. That just means then everything to the left of -2, my derivative is positive, which means then that my function is increasing. Let me not draw that yet. Okay, well, let's just finish off this sign chart for my first derivative. And I also want to test between -2 and 7. Well, what's a nice value, nice easy value to choose between -2 and 7 that I can plug into my derivative? It's my derivative that I'm plugging it into.
0 or -1.
Yeah, 0, -1, +1, any of those would work. 0 is the easiest. Because this would be 0 squared minus 5 times 0 minus 14. This would be a -14. And that is what, a positive number or a negative number?
Negative number.
I see you in chat, Shanice. That's awesome. Yeah, so it's a negative number. Okay? So that means everywhere between -2 and 7, my values are negative. My derivatives are negative, which means now my function is decreasing. And then after 7, I got to plug in a value. Whoops, I want to keep this in green. I don't know, just plug in 8. So this would be 8 squared minus 5 times 8 minus 14. And just for the sake of time, I'll tell you, while you do this calculation, you end up getting a positive number. You're welcome to finish the calculation on your own. But you'll see that's positive, and that means for my derivative, everything to the right of 7 is a positive value. So then for my actual function f, for my actual function f around these values, because of how we know the derivative relates to my original function, this means in everything to the left of -2, I'm increasing. Between -2 and 7, I'm decreasing. And then everything after 7, I'm increasing again. So then which of those 2 points, -2 or +7, is showing me the same behavior that I would have for a relative max? Because only one of them does.
-2.
Yeah, -2. That's where I see myself increasing, then decreasing. Increasing, then decreasing. That's what we see for relative maxes. Anytime my derivative goes from positive to negative, it means my function is going from increasing to decreasing, which means I have a relative max. So I don't want to go away from this page. I guess I just got to kind of cram it up in here. So at x is equal to -2, that is when we have a relative max. Oh, that's a bad grammar. Let me rewrite that. Where a relative max occurs. So when x is -2, we have a relative max. So your answer in this case would have just been x being -2. That is where we have a relative maximum occur. Okay, what about, just as wasn't asked in the question, right? But what about at x equals 7? What do we have there?
A relative min.
Relative minimum. Relative
No.
minimum.
Yeah, 3 people this time. Yeah, relative minimum, right? Because I see, based on the sign chart for my derivative, this means my function is going from decreasing, getting closer to 7, and then increasing after 7. So we kind of see this nice little dip. And that's always an indication that type of behavior in our graph, we have a relative min. So at 7, x equals 7, we would have a relative min. Don't really have room to write it here. I'm trying to keep all this information in one spot. This is why I wish I had this nice big old whiteboard. Kind of partition this stuff a little bit nicer. But that's first derivative test. Just check the sign of your derivative compared to your critical points. Where am I positive and negative for my derivative? That tells you where you're going to have relative max and relative mins. Anytime you switch from positive to negative, you have a max. Anytime you switch from negative to positive, you have a min. So questions? If not, please give me a thumbs up. But please, please, please ask questions if you got them. So most people give a thumbs up, but I don't hear any questions. All right, so this is just one way to go about this. Okay, one way to find relative maxes and relative mins. The second way is to use your derivatives again. Specifically use the second derivative. You get what's called the second derivative test. Okay, but before I go into the second derivative test, we have just another terminology, another thing we like to study with second derivatives. It becomes really important for graphs, but in the pose of me trying to condense this into a short amount of time and keeping the question about relative max or mins, doesn't seem related, but it is an important concept for us. Okay, so where my original function is equal to 0, those are called roots or zeros, right? And that's just terminology from our algebra days. What we built, where my derivative is equal to 0, those are called critical points. Well, why did that switch to yellow? Wherever my second derivative is equal to 0, these are called inflection points. Inflection points. Let me see if I can write that a little bit nicer. That's better. So where my second derivative is equal to 0 is called inflection points. So just trying to take a nice little cubic graph, like what we've seen before. Looks something like this. And when I look at these graphs, I have something called concavity. A concavity is what is the cavity of the graph facing? What direction is it facing? Well, if I kind of fill in, consider this a cup, right? Kind of to the left right there where I shaded in that green, I see a cavity, right? From that hump at the top, I have a cavity. And what direction is that cavity facing? To look like? Not up, the hump is going up. The cup,
Concave down.
yeah, cup that I have, the opening for the cup is a way you can think of it, is facing downward. So in that green area would be concave down. But then at some point, I can see that that graph actually switches from concave down to concave up, right? The cup that I'm visualizing is now looking like this. The cavity is facing upwards. That's going to be concave up. So I guess concave down, concave up. And the question is, where does that change? Well, that's at that inflection point. So somewhere about right there is where my concavity changes. That's when my second derivative is equal to 0. So again, finding inflection points is the same process of finding your critical values, essentially. You just have to take another derivative. Because inflection points are not when my first derivative is equal to 0, it's when my second derivative is equal to 0. Okay. Then, once I have that second derivative, though, I can still take this back to this idea of, okay, can I use this information then to test whether or not I have relative max or relative min? Now look at where I'm concave down. Concave down. What do we see? Do I see a relative max where that hump is or a relative min? So,
Relative min.
oh man. So if I drew a tangent line right here, yeah, it'd be relative max, right? Where I see myself increasing up into that point and then decreasing. So I see a relative max here. And that's not a coincidence. Wherever my graph is concave down is where I'll have a relative max occurring, if there is going to be a max there. And if I look at where I'm concave up, what do I see?
Relative min then.
Yeah. I see a relative min. So if the second derivative test just tells me, or second derivative tells me where I'm concave up or concave down, then I just need to say, okay, well, is my concavity negative or concave down? Is my concavity up or my second derivative positive? And that is automatically going to tell me whether or not I have relative max or relative min. I don't necessarily need to do this line chart. That's where we get this second derivative test. Okay, the second derivative test, the first step is always still find critical points. Okay, still find your critical points, because even if we're going to use first derivative test or second derivative test, that is where my relative maxes or relative mins will occur. Okay, no ifs, ands, or buts, always that thing. So always take the first derivative, set it equal to 0. But then the second thing I do is find the second derivative. So I take the derivative again, and then I'm going to plug in those critical points. So find the second derivative and plug in those critical points. Okay? And then I get two cases. If when I plug in that, let me not use that dash there. Case A and case B. If I plug in that critical point into my second derivative, and my second derivative is negative, this means that I am concave down at that point. And we said if we are concave down, based on that image, that means we have what occurring? Relative max or relative min? See Debbie give me a thumbs up. I'm assuming that means max. Yeah, there we go. So I saw some people unmute, they just didn't get a chance. Yeah, someone put it in chat. Yeah, relative max. So if I can plug this critical point in my second derivative and it's a negative number, this means that we have a relative max. At that point, x equals c. At that particular critical value, we have a relative max. If I plug it in and it's positive, that means my graph is concave up at that point, which means I have then a relative min. And then we have this third case that if I plug in that critical point and it makes my second derivative 0, really, we have no idea. The second derivative test fails, which means you always have to go back to the first derivative test. And you have to go back to the first derivative test, use that to then figure out whether or not you have a relative max or relative min. Okay. So you now have a new question up on poll everywhere.
Wait, can you say the last thing you just said again? Because
Yeah, sure. So if you plug in the critical point into your second derivative and it equals to 0, second derivative test fails. It doesn't tell you anything, right? Because what that's telling you is neither concave up or concave down. So you have to use a different test. Really, the only test we have is the first derivative test, and then determine if it is a relative max or relative min.
okay. Is it possible that one of the points could be equal to 0 and the other one would be a thing, like a max or min?
So from the lens of the second derivative test, you can only say one of them is relative max or min, other one to be determined.
Okay,
And then to determine the other one, you have to go to a different test.
Okay.
Mhm.
Thanks.
This one, second derivative test is usually preferred because I just have to calculate a derivative twice, do function evaluation again, and then I immediately have, just based on signs, whether or not this thing is relative max or relative min. Because again, I don't have to do the actual calculation. I'll have to figure out what the second derivative is exactly at that critical point. Just got to figure out if it's positive or negative. So the first question I have up for you is inflection points. Okay. So I just wanted y'all to calculate inflection points really quickly. Again, that is where the second derivative is equal to 0. So you notice this is the same function. You've already taken the derivative once, right, in the previous one. So now just take the derivative again. So the derivative of the derivative, set it equal to 0, and solve. I'm just going to give you all, I know it's not a lot of time, but I want to make sure we're out of here relatively close to 11:50. So I'm just going to give you all about 50 more seconds. About 50 more seconds, if it helps. And all for f of x, which we said was 1/3 x cubed minus 5/2 x squared minus 14x plus 1. We said the first derivative was x squared minus 5x. Whoops. Minus 14. We need to figure out what the derivative of that is. The derivative of my first derivative. All right, like I said, I know it's not a lot of time, but I'm going to make sure, and at least the answers that I see so far are good, except for one. I'm just going to give you all 20 more seconds to finish typing it in. And again, inflection point, this one I can see where it's misleading, especially the way I've been trying to train y'all. That really we just care about the x value when we ask this question. We're not caring about the entire points, not the x and y value, not that pair, just the x value. All right, I'm going to lock answers here in 5, 3, 2, 1. Locking answers now. Cool. See you, baby. So I take the derivative of my first derivative to get the second derivative. So I take the derivative of x squared minus 5x minus 14. This gives me 2x minus 5. I'd plug this, or not plug this, set this equal to 0. Solve for x. And I'd see that my inflection point is at 5/2. So where my function switches from concave up to concave down is at 5/2. Okay. So next question, and this is about the second derivative test, is now up. I just want to make sure you saw inflection points really quickly. Let's use that second derivative test. So just be careful. This function is slightly different. It's off by one sign. Okay. In this case, we have f of x is 1/3 x cubed plus 5/2 x squared minus 14x plus 1. And this time I want y'all to use the second derivative test. You can use the first derivative test. It'll come to the same conclusion, but I want you to practice using that second derivative test. Okay, so I guess I don't have time to just wait, let y'all try to practice some, and then I go through it. So I'm just gonna go ahead and start. You're welcome to try to work on your own, passively listen, and see if we come to the same conclusion, or just follow along with me. Okay. But either case, again, first step, always when we're trying to find relative max or mins, is find my critical points. Find where I may or may not have a relative max or min. So I need to take the derivative of this function, which because of that change in sign for the second term means this is now going to be x squared plus 5x minus 14. And I set this equal to 0. In factor, this time it'll factor into x plus 7 and x minus 2, which means then my critical points are going to be when x is negative 7 and when x is positive 2. And so this function that has slightly different critical points. Now, I want to use the second derivative test, which means I need to find the second derivative. All that means I then need to take the derivative of x squared plus 5x minus 14, which then means that my second derivative will be 2x plus 5. After that, plug in my critical values. So I plug them into my second derivative. The first one is negative 7, which means then this is 2 times negative 7 plus 5, negative 14 plus 5, which is a negative 9. Again, yes, we can calculate that value, but what we really care about is the sign. This is telling me then at negative 7, my second derivative is negative. So what do I have at negative 7? A relative max or relative min?
Min?
Min. It's kind of counterintuitive. We have a max. Thank you, Shanice, for putting it in chat. So remember that negative means I'm concave down. My cavity is facing downwards. Thus, if I kind of look at that shape in my head, keep that shape in my head at all times, this means at x equals negative 7, we have a relative max. And then just for the last one, I want to plug in 2, right, my other critical point, into my second derivative, which means this is 2 times 2 plus 5, or 9. And again, I can calculate the actual value. That doesn't really matter. All I care about is the sign. So at this point, my second derivative is positive, which then means that my graph is concave up. It is facing up. The cavity is facing upwards, which means then I have what? Relative max or relative min?
Relative min.
Yeah. So then, yep, thank you, Shanice. At x equals 2, we have a relative min. So that's how we use the second derivative test. Okay? Questions? Cool. It's just really quickly while we're here and you're finished writing that down, you can passively listen. If I would have done that sign chart with my derivative, so essentially the first derivative test, again, I have to do negative 7, positive 2 for my critical points. I plug in a value into my first derivative that is less than negative 7, so something like negative 8. But then you would see that, what is it? It would be positive. Should be positive. Between -7 and 2, you'd plug in something like 0. You'd see that it's negative. And then if I plugged in something greater than 2, you'd see that again, I'm positive. So again, just looking at my first derivative test, I see my first derivative going from positive, negative, positive, which means, again, from the first derivative, I have a relative max at -7. So I'm going from increasing to decreasing. And then at 2, I have a relative min because I'm going from decreasing to increasing. So I don't want to throw that side note in there. Both of them, again, come to the same conclusion, just two different ways of going about finding it. Okay, so, all right, I'm done talking. Any questions? All right, some people are giving me the thumbs up. Cool. So, announcement. Wednesday is another university holiday, okay, which means we don't have an actual class. However, I still want to cover L'Hopital's rule, which I was not able to kind of put in at the end of this. It's another really cool derivative application. I have not decided whether or not I'm just going to try and create a video like this in Zoom, do some examples, just say pause it, go work it out, and then resume it when you're done, and then I go through the problem. Or if we're just going, if you want to have a class on Wednesday that is not required for you to be there. Okay, I have not decided which path I want to take, but I'll let y'all know by 5 p.m. today. Either way, it's just going to be something that if we do have a quote class on Wednesday, there will not be a daily quiz. I'm going to make sure that it's recorded and posted immediately afterwards. So if you don't show up, you still have time to watch it. Okay? But I'll let y'all know by 5 p.m. today what path I'm going to take, because I still need a little bit extra time to go through that. Okay? Okay. Yeah. But yeah, I will be, like I said, if we're gonna meet on Wednesday, I'm gonna try to keep the same style, but no daily quiz. I'll post the recording after. Okay. All right. So that is it. I'm finally done. Sorry for the recording not starting until like 15 minutes in. But I think we got most of the important stuff. So if you are feeling good, you are free to go. Not, you're welcome to stick around and ask a question. Or questions if you have multiple.
Professor Rapp, I have a question.
Yeah, what's up, Destiny?
So I know we have a test on the 18th for this month.
So it won't be on the 18th. Is that what I have in the syllabus?
Yeah, that's what you have in the syllabus.
Cool.
You have the 18th to the 22nd.
Cool. So I'm going to be pushing. Good thing for asking that, because I meant to update that. I'm going to be pushing it back just a little bit because that last week we're still going to have material that I want to cover.
Mm-hmm.
You'll have a homework on the 21st, and then my plan is like between the 22nd and 25th, you'd have same setup of online portion that you'd have 45 minutes to do, and then a written portion that you'd have to submit before midnight on the 25th. And of course, you could finish it before midnight on the 24th, and that way you have all of Thanksgiving, you're done with this. But if you need that extra day, that's why I might do it on the 25th. But that's a good thing. Let me make a note of that and make sure I get that updated. And I'll also make sure I'll tell y'all by 5 o'clock today.
Okay, thank you.
Yeah, no, thank you for bringing that up because that's kind of important. Any other questions? Yep, go ahead.
I was just checking now. I didn't have a question, but now that we're talking about schedule, so those changes will be in the new, or you'll update them.
The syllabus, I'll send out an announcement as well.
The final exam is still the 4th, it was, I think, right?
Yeah.
Okay,
that's
good.
Set. It'll probably be the same idea that like maybe just 2 days around the 4th, since all you have is exams.
Sure.
versus multiple days. But it'll be the same idea because I don't want to just change it up on y'all. Do a completely different style final.
Okay, thank you.
Yeah. Any
I
other
have a
questions?
question.
Yeah, go for it again.
Sorry. Do you know the format of which the final exam is going to be in? Is it going to be written online or?
Good question. I'm going to keep it the same. So unless just like it won't go crazy, or why am I getting a check here? Hold on. When is final? Oh, anyway, sorry, you're sending it to the internet. It's on my iPad. That's why I haven't seen it here yet. Destiny, it's going to be the same idea. 70% of your credit will come from an online portion, since that's mainly where you've been doing your work, and then 30% written. So we can make sure that you're still able to convey it correctly. So not only get to the right answer, but have the right logic. So that's what I plan to do for the final as well.
Okay.
Amelia, it should be August, or not August. Wow, wrong month. December 4th. Whatever is in the syllabus. I know that is absolutely correct. I think it's December 4th, especially from what Dezante said. All right, any other questions?
I'm good.
Cool. All right, well, I'm going to go ahead and end the meeting. I'll see y'all later.